Hi, welcome back to part 2 of characteristics of measurement. As before, we have talked about systems, okay, linear, nonlinear type. Now we're going to go into static characteristics. But before we go there, let's talk about this thing called reproducibility or repeatability. When you do measurements, it has to be verified. What do you mean by that? Which means when measurements are made in a controlled environment, such as a research lab like what we are doing, it is designed to be reproducible, which means people can repeat your own experiments, and they should get the same results. If that's not the case, we're gonna have a problem. Okay. However, when some measurements are made under field conditions, which means in the field, like uh, for example outdoors, or um, even in a factory, okay, things might be different because you might have hot sun, you might have air conditioning, you have loading. There's a lot of different factors that's involved that may interfere with the reading. That's why when we are making measurements, right, we have to be aware of the different factors that will affect our measurements, and that will actually contribute to whether the reading can be reproducible. Why we want to do that is because things are made to be done over and over again. So I have to make sure that the reading is, so the measurements has to be repeatable. If not, that would not be a good measurement system. Okay. Now let's talk about static characteristics of each uh, measurement system. When we talk about measurement system, we have to talk about these three things and also these two things, but we are more concerned about these three. Accuracy, how close the measured value is to the true value. Meaning to say, for example, okay, your body temperature, the actual is actually 38 degrees, which means you're having a fever. But your measured is 36 degrees. Is this accurate? No, this is not accurate. So accuracy is very important. What about precision? Talk about accuracy. So let's talk about precision, which means how alike the repeated measurements are taken. So, for example, you take a ruler and you try to measure a certain cylinder, okay, certain cylinder, and you try to measure it. First reading, you have 6 cm. Second reading, you have 8 cm. Third reading, you have 4 cm. So, is this ruler accurate, or are you measuring it correctly? That's what we mean by precision. Are you able to repeat your measurements? Next thing we need to talk about is resolution, which means how fine. The keyword here is fine. How fine is your measurements? For example, you have a scale. So you have 0 and 10 versus a 0 and 10, but with 10, but with 0, with a different marking of 1 cm, for example. So this has a better resolution, and this has a low resolution. Okay. Next thing is sensitivity, which means the change in measured versus the change in true values. So take for example, body temperature again. Okay, an increase in 1 degrees in your measure versus your actual, it should be the same for it to be very sensitive. Okay, which is 1 and 1. This is corresponding sensitivity. Okay, so if I have a measured one versus the a measured one, I get 0.01 degrees Celsius versus your actual, you have say 1 degree. This is much more sensitive in that sense. What about zero drift? Zero drift talks about the stability of the output over length when the input is 0. So when I give 0 volts, for example, into the system, it should give me 0 volts. Okay, this is the start of time. Okay, so as time goes on, if 0 volts into the system, you get 0.0001 volts actual. So it has a slight zero drift here. Okay, that being said, we have covered most of the characteristics of a measurement system. Next, we're going to talk about input loading. This, I will just stop here. So we're going to talk about this later on. And that will be end of this little segment on